Welcome to Study Loop.
Hi, in the given problem, here this is the horizontal turntable at which this is the coin placed at a distance of 30 centimeter, which is supposed to be radius of the path of the circular path of this coin. So the radius comes out to be 30.0 centimeter, or in meter we can say this is 0.30 meter. The maximum speed at which the coin will remain at rest over this turntable is given as 50.0 centimeter per second, or we can say this is 0.50 meter per second. In the first part of the problem, we have been asked what force will keep the coin at rest when the turntable will be moving. Of course, when the turntable will move, the centrifugal force acting on this coin will try to throw the coin radially outward. But actually what will happen, if this is the coin, this will be the force, centrifugal force acting on it radially outward. The force of friction acting on it radially inward will keep the coin at rest in its position. If the mass of the coin is m, so its weight will be mg. So the normal reaction acting on the coin due to this turntable will be n, which is nothing but equal to mg. So force of friction is given as mu s, where mu s is the coefficient of static friction. So this is mu s into n, and we know n is equal to mg. So we can say force of static friction becomes mu s into mg. So the answer for the first part is static force of friction acting between the coin and turntable inward radially will keep the coin at rest against centrifugal force, which is radially outward. Now, in the second part of the problem, we have to find the value of this coefficient of static friction. For that, this force of friction should be equal to centrifugal force, or we can say mu s into n should be equal to mv squared by r, or we can say mu s into mg should be equal to mv squared by r. Here m get cancelled. So the expression for mu s, the coefficient of static friction, comes out to be mu s is equal to v squared divided by r times g, where r is the radius of the circular path, g is the acceleration due to gravity. So when we put these values, this becomes 0.50 square divided by radius, which was 0.30 into 9.8. So this value finally comes out to be 0.085. So this is the coefficient of static friction. Thank you.